Hello friends, it's me Mohnish and today we are going to discuss about a new data visualization project. So it's a hard graph and we are going to study the BP and diabetes of the people and we are trying to give some conclusions from it. So let's get started. Let's pick up that CMD here and let's type a command Jupyter notebook. So this is done in Python using Jupyter notebook. So it will just open in a while. So done. So this is the file and this is the hypermemory. So this is a heart disease CSV which I like was provided from the Kaggle, and then here comes the main thing. So what I'll just clear all the output. So we are done with clearing the output and here you see the notebook. So find the diabetic and the high blood pressure patients across all the age groups that conclude the risk of heart stroke is higher. Like we need to find a diabetic and like high blood pressure patient across all age groups and we need to conclude like who has the higher risk of heart strokes or heart attacks. So as usual import pandas and import pyplotly because we are working with a like CSV file, so we need pandas, and then we are working with plots. We need to like at the end of the video we'll be plotting a pie chart, so we are using the pyplotlibs for that, and here we are having the CSV file heart CSV, and that's the thing. And then we are locating the diabetes, and if it is equals to 1, so why are we doing this? Like, let's run the output, yeah. So it will be good to understand. So you see, this is the data frame. So if I look at diabetes, so 0 means he doesn't has any diabetes, and 1 means he has diabetes. So that's how the data was provided, and we are just locating wherever diabetes is 1. So you see, we get all the diabetes one. So this was 299 columns, out of which 125, sorry, 299 rows, and out of which 125 rows have, like the people have diabetes. So it's not a big data set, only 300 rows. Uh, like 0 is also a row, this thing. So we get total 300. And then we are going to group by age and diabetes, and we are going to count. So if you understand, we are grouping by age and diabetes and we're counting like how many people, like how many age, like if age is 12, for example, okay, I'll take some reasonable age like 19. So if it the age is 19, then it will count the number of people it like who have diabetes, and we are using the reset index because we don't want random indexes like like I did not use reset index here, so you see 4 7 19, like it's disturbing for some, it's annoying to some extent, so we use the reset index here. So now you see we have a data frame of age and diabetes. So in the 40 age group, we have two diabetic patients, 45, 11, and all that. So wow, got it. And then we are taking the blood pressure here, like blood pressure. You understand what do you mean by blood pressure? Yeah, pressure in your blood. Yeah. So if it is 1, similarly, if you see the data, you have zeros and ones. 0 means no blood pressure, like low. What is a normal? 120 by 80. Like that's considered normal across the world. So if they have high blood pressure like 150 or 180 also, sometimes they like, I saw people having 180 by 115 pressure also. So now you see we got all high blood pressure patients, but all of them are not diabetic. You see that. So we are going to find the correlation between diabetes and high blood pressure now. So you see few are diabetes also and high blood pressure also, so we are going to find a correlation now. So we are just going to group by age 41 high blood pressure, 45 5, 50 10. So you see here 70 you have 13. So to simply conclude, we can say 70 like the people of age group 70 have high blood pressure, like 13 out of 300, according to the data set. And then here we can say diabetes. 60 age group is the mm, like the age you can get diabetes, like 19 out of 300. And few of these are repeated. You understand? Like here 125 rows and here 105 rows. In that, few people are repeated. So we are going to work with the repeated people. Like not repeat, like the repeated people are at a very dangerous stage. So we want to get a graph here. So you see, like this data does not give a perfect correlation between diabetic and high blood pressure level and age group. Like because the data is very less and it's very difficult to conclude like the correlation between these two graphs. So we can't really conclude anything. So uh, we can just conclude diabetes like is analogous to high blood pressure and all and all the things. So you see like this 2.5 like these are the number of people who got it. So you can see diabetes is more in 60 and then blood pressure is the most in 70. So that's what we read. But we can't conclude like diabetes and high blood pressure correlated between each other in the age groups because everything is like we'd have less data to conclude that. So let's go and we are going to find as per the gender who has normal platelet level. So here we are having gender and platelet level also like okay, where is that? Yeah. So you have age and what we are going to platelets. So this is what we are going to think about and the gender. So you see, so gender and platelets is what we are going to work with now. So we are going to find a correlation between the gender and the platelets. So here platelets we are locating platelets which are lesser than 15,000 or greater than 45,000. Like just for like we are just filtering like we don't want all the data. Like if we just keep the platelets like all then it can be good, but we want a range. We don't want all the platelet levels. So you see here, as we did not apply reset index, the annoying numbers are annoying us. Right? But I'll just apply the reset index. It is good. Reset underscore index. So yeah, this is much better. So you see platelets. Yeah, yeah, yeah. Platelets, yeah. So now we are going to group by gender. So we are grouping by gender and platelets and we are counting it. So here gender zero is I think female and one is a male. Here, yeah. Zero is female and one is a male. Or it can be vice versa because I did not read the thing before. I think I'll just see the gender part once more. So yeah, gender skin ones and zeros. I think probably one will be man and zero will be females and like we'll just assume it for now. And then if you plot a graph, you see you get female 26% and like male 73%. So this have males like percent of males not having normal platelets in the blood is higher than that of females. So you understand like this was the abnormal range, like uh not so much abnormal, but then also we just considered here as abnormal, like this range. And we are trying to figure out how many percentage of male and female out of the 300 data set have abnormal conditions. So this is not a very big data set to get accurate like visualization, but according to this data set, we have visualized a lot today. So that's it for the video, friends. If you like this video, just share it, boom it everywhere. Like this video, subscribe this channel, and I'll be coming with a video soon. Till then, take care and bye bye.